All right. So, hello and welcome everyone. So, welcome all of you. I hope we are live right now, right?
All right.
So, welcome back. Welcome back to this amazing platform, Tutee Learning. And as we were discussing with circles, so let us continue our ongoing discussion on circles, right? In today's session, we are going to discuss about the condition of director circle. And along with that, we're also going to understand and try to solve some questions on the number of common tangents, right? And what are the conditions for having common tangent and all those I'm going to discuss in this particular lecture, right? So with this, let me first of all ask you all of you that I hope you have finished solving this homework problems in the previous discussion, right? So in the last class, which I have taken like 2 days ago, I hope I gave you these questions to solve, right? And I pretty much sure that you must have tried to solve it. And this question are very straightforward, so I am very much sure that you must have also got the solutions of it, right? So maybe you can let me know the answers what you have got in the comment section of this particular video, right? But or maybe the previous video. So let us today start with our concept that is going to be director circle, right? So today's class we are going to discuss about director circle. Right. So what is the concept of director circle and why is this important? So this particular concept of director circle will definitely come up in all the portion of conic sections, right? So for a given curve, you will be asked to find out the director circle, right? So what is the director circle? Director circle is nothing but the locus of point of intersection, locus of point of intersection of two two perpendicular tangents. Okay. So if you have two perpendicular tangents to a given curve, then the locus of the point of intersection is going to give me the director circle. So it is also simply known as the locus of the point of intersection of the perpendicular tangents, right? So let us try to understand how we'll try to plot this particular thing for our case of a circles, right? So if we try to draw a circle over here, like this, with a center at C. So if I try to draw two perpendicular tangents, something like this and this, right? So this is going to be perpendicular tangent. Let us say that we draw a tangent as point A and point B. And let us say the tangent will intersect at point P, which is given as x comma y, right? So that equation, what this particular point of intersection of two perpendicular tangent is going to make, or that particular curve which this P of x comma y is going to make, that is nothing called as a director circle, okay? Now please make it sure that director circle may not be always a circle for any given conic section. For example, in case of a parabola, we do not have a director circle as a circle. We have it a straight line, right? However, we call it a director circle because we define the director circle as a locus of the point of intersection, right? So maybe for some conic section, you won't get a circle as well, right? So please take this note very carefully because it is going to be very, very useful to understand the results in different conic section as well, right? Now, our main understanding over here is basically how do we find out, or how do we reach to this condition of to find out the equation of the director circle, right? So if I say, let us take the simple case and try to solve it. So if I say this is my equation of the circle, okay, this is my equation of the circle, okay. Let us say this is my equation of the circle with the center at 0 comma 0 and the radius is a, right? So let us say this is my equation of circle, and let us try to write down the equation of tangent, right? So let us try to write down the equation of tangent, and I will be writing down the equation of tangent in the slope format, right? So let us say that the slope of any one of the tangent is given as m, right? So if I write down the slope form of the equation of tangent, that is basically mx plus or minus square root of 1 plus m square multiplied with the radius, that is a, right? This is my equation of the tangent in the slope format, right? This is my equation of the tangent in the slope format. Now interesting is that the point of intersection is definitely going to lie on this point, on this particular equation of tangent, right? So therefore, if I say the point of intersection is some h comma k, then this will be satisfied for h comma k, right? So if I try to simplify this particular part, so what I'm doing is that I'm just substituting h comma k into it, right? and then I will obtain some relation like this. Okay. Now we have already learnt about what is the standard procedure for finding out the equation of any general conic or any general locus, right? So first of all, whose point or whose locus we want to find out, we have to assume that as h comma k, right? As that particular point as h comma k, and then we try to replace that h comma k with x comma y once we have already removed all the unknown variables from that particular equation, right? So we will do the same thing over here. So our variable over here is basically a, this uh, a in our given formulation, right? So from here, if I take square on both the side, what will I get? So if I take square on both the side, so I will get some ms square, and then I simplify to make it as a quadratic in m. So I will get ms square times hs square minus a square minus 2 times of hk plus k square minus a square, right? This is the quadratic I will get in terms of m, right? Now this is my quadratic in terms of m, right? Now what is the condition that this h and k needs to satisfy is that these are the point of intersection of two perpendicular tangents, right? So if my two tangents need to be perpendicular, so from here, what is basically giving me the condition is that this is a quadratic equation which is basically giving me the two slopes for that particular straight line which is passing through the point P, which is whose coordinate is h comma k, right? Now very important is that these two lines are perpendicular lines, and therefore I will have m1 into m2 should be equal to minus of 1, right? Because we have learned that in case of perpendicular lines, the slope of the product of the slope should be equal to minus of 1, right? So if I just substitute it over here, then, and we know that this is the roots are m1 and m2, so the roots are m1 and m2. So if I try to find out the product of the roots from this quadratic equation, it is going to be equals to k square minus a square divided by h square minus a square, and that should be equal to minus of 1. So from here, if I simplify, I'll get some equation as h square plus k square should be equals to 1, right? And therefore, sorry, should be equal to 2 times of a, sorry, should be equals to 2 times of a square. So from here, my locus equation, so from here, the equation of locus, right? So from here, the equation of the locus can be now obtained by replacing this h comma k with x and y. We have already replaced, and this is basically equals to 2 times of a square, right? So this is what I'm getting the locus of that particular point P as x comma y. So therefore I have solved this x comma y and I've got to a constant expression, right? This, right? So this is the required expression of my locus, right? So what you understand over here is that the director circle of a given circle is also a circle, with the same center, C, and the radius is only root 2 times a. So the only changes we have in the director circle result for a given circle of radius a is that the radius get multiplied with root 2 times. Okay, so the radius is only increased root 2 times. I hope this result is clear to all of you. Is this part clear? So let us now discuss about this is very good lecture, easy to understand and appreciate it. Thank you. Okay, great. So I hope you have understood this particular thing. Now, this is basically how you obtain the equation of a director circle. Okay, so maybe in any of your conic section questions, when you will be asked to find out the director circle, the simple result you have to perform is that you have to find out the locus of that particular point of intersection of two perpendicular tangents. Okay, so if you do that, you will be easily able to get to the required locus. Okay, all right. I hope this is clear. Now let us move ahead and let us try to explore the concept of intersection of two circles. Okay, let us try to come across this concept of intersection of two circles. Okay, intersection of two circles. Okay, so for that, let us take two circle equation as, let us say my first circle is given as x minus x1 square plus y minus y1 square, and let us equals to r1 square, and let us say the circle 2 equation is given as x minus x2 square plus y minus y2 square is given as r2 square. Okay, let us say we have this two equation of my circle, right? Now, what do we actually mean by intersection of circle is that we need to try to understand whether the circle will intersect at one point, whether the circle will intersect at more than one point, like 2 points, or whether the circle will never intersect, right? So we'll try to decide each of the cases, and for corresponding case, we will also try to write down that how many common tangents can also be drawn to that particular circle if my following case exists, right? So let us start with the very first case. Let us consider this is my case 1. So if I talk about case 1, let us say when my center to center distance, that is basically C1 and C2, if this center to center distance is greater than, so I'm putting a mod of it, is greater than my R1 plus R2 distance, so whatever is my radius distance or the sum of the radius, if my center to center distance is greater than the sum of the radius, then obviously the circle is never touching each other, right? So this particular thing is saying that the circle, okay, do not touch. Okay, the circle do not touch. What can be a simple example like this? So if I try to draw it, some case like this, let us say this is C1 and let us take another circle which is C2, right? So the circle center to center distance is this particular distance is greater than the distance of the radius R1 or sum of the distance of the R1 and R2, right? So from here we can easily say that if my this particular condition is existing, then the circle is never intersecting each other, right? So for this particular circle, if I try to understand how many tangents can be drawn, what I can do is that for common tangents, so for common tangent like this, we will have one, so we will have one, two, right? So we will have two this kind of tangent, and also we'll have one more this kind of tangents, right? Okay, so these particular tangents which are drawn like this manner are called as direct common tangent. Okay, so I'm writing C dot T means common tangent, and this kind of tangents which are basically going transverse are basically called as transverse common tangent. Okay, so these are the two different types of tangent we will have. So in total we will have four common tangents. Okay, so in this case we'll have four common tangents. Okay, so the interesting case is that when the circle is not intersecting each other, then we'll have four common tangents. Out of them, two direct common tangent and two transverse common tangent, right? Similarly, if I give you the case that what happens if I get my, now if I get my distance C1 C2 to be exactly equals to the sum of the radii of the two circles. Okay, so what happens if I have my center to center distance equal to the radius of the distance or the sum of the radius? That means the circles are touching each other. Okay, that means the circles are touching each other only at one point, right? So if I say this is my C2, let us say this is my C1, so what is this particular distance C1 C2, and that should be equal to R1 plus R2, right? So if this is existing or if this is held truth, then this particular circle I can say that they are basically intersecting at one point. Okay, at one point. Okay, so this particular thing says that the circle is intersecting at only one point. Now for this case we will have two direct common tangents, we'll have two direct common tangents and only one transverse common tangent. Okay, so for this particular case we'll have in total we will have three common tangents. Okay, so in total we will have this three common tangents. Similarly, if we take another case like this, that what happens if my C1 C2 is less than R1 plus R2. Okay, if my C1 C2 is less than R1 plus R2, then what might happen, that we might have 2 points of intersections. Okay, so we might have, this is my circle 1 and this is my circle 2. So in this case I will have the C1 C2 distance is less than the sum of the radius, then this I can have 2 points of intersection, which is basically these blue dots, right? And then if I try to draw the tangent like this, so I will have only two common tangent in this case, and two of them are only direct common tangent. Okay, so in this case the circle intersect at 2 points. Okay, the circle intersects at 2 points. Okay, and lastly we might also have a case where, so we might also have this particular case where my C1 C2 distance is equals to the difference of the radius, where my C1 C2 distance, center to center distance, is equals to the the subtraction of the or the difference of the radius of the two circles. What is this case denoting? This case actually denotes that another circle, one of the circle is lying completely inside the another circle, right? Like this, something like this. Okay, so let us say this is my C1 and let us say this is C2. So in this case, C1 C2 is equals to R1 minus R2, right? So this is the case when the circle is lying inside. Okay, so this is the case when the circle is lying inside the bigger circle. So if the smaller circle lies inside the bigger circle, so that's what I'm writing over here. Smaller circle lies inside the bigger circle, right? And in this case, you will only have one common tangent, and that is the tangent at the point of contact. And so you will have only one common tangent. Okay, so in this case, we will have only one common tangent. I hope this is clear to all of you, right? So basis of this, we can also have different set of questions, and also one more case can also be formulated is that we can also have this last case where my center to center distance is less than also R1 minus R2. In this case, it is completely inside, right? It is not even touching the circle, right? So something like this, we have one circle over here and a circle over here. So this C1 is C2. In this case, we have no common tangent. Okay, so this particular case where the circle is completely inside, it is having no point of intersection. So in this case, we have no common tangent. Okay, so these are the all 5 cases that you need to take in mind while we solve questions, right? Now, the most important types of question that can be asked over here is to find out the length of the common tangents, right? So for example, let us say in this particular case, you might be asked to solve for the case of the find out this length of the, let us say this particular point is A, let us say this particular point is B, and this particular point is P. So we have to might be to find out this particular length, right? Or it might be a question like to find out this to this particular length, right? Or maybe a question only to find out this AB length, right? So this kind of questions can be asked up, right? So we can always use our geometrical understanding to find out this length of this tangents, right? So for example, if I want to calculate the length of this exterior tangent, that is basically AB. So geometrically, if you try to solve it out, it will come out to be. So for solving this AB, what I have to do is that from point P, I have to plot a perpendicular. I have to draw a perpendicular on AC1. Okay, I have to draw a perpendicular on AC1, and that particular distance is going to be capital D or small d, sorry. And therefore, my result for this length AB distance is going to come out as D square minus R1 minus R2 whole square. Okay, this is what the result will look like for the case of the length of the external tangent. Okay, so length of the external tangent will look like something like this. Please note that this from B I am dropping a perpendicular onto this line AC, right, which is very easy to find it out. Similarly, if I want to find out, let us say this particular point, let us say T, let us say if I want to find out the distance of I want to find out the distance of dt, then that can be easily found out as square root. Again, this d distance is the same, so in the d distance it is d square minus r1 plus r2, right? Now the easy trick to remember this to formula is that now we always obviously know that AB distance of this external tangent is obviously greater than the transverse common tangent, right? This particular AB distance must be greater than the CD distance, BD distance, right? So therefore, in order to remember this result d square minus r1 minus r2 is basically a smaller result. So you are subtracting from a large number a small quantity. That means the number is still large, right? But in this case, r1 plus r2 is a large quantity. So d square minus that large quantity will make it a small quantity. So therefore, it is obvious that your AB is greater than BT distance, right? So length of the external tangent is obviously greater than the length of the internal common tangent. Okay, so please take a note of this. Okay, because this is a question that has already been asked so many times in your JEE Mains paper. Okay, so please take a note of this particular theorems and all this understanding, because it is going to play a crucial role, especially when you start to solve questions. Okay, so now what I'm going to do is that I'm going to show you some of the previous year JEE Mains problem, and from those problems we will try to find out or we'll try to solve for the required results, right? Okay, so a very interesting question that was asked previously was something I'm showing it over here. Okay, so this is a very interesting problem. You can try it out. You can all try it out. So here we have to find out the equation of a smaller circle that touches the circle, let us, this which is given as x square plus y square equal to 1, and also passes to the point 4 comma 3, right? So in this question it is saying that the other circle or the smaller circle is touching this bigger circle at only one point, right? So what I can understand from here is that if I have a smaller circle like this and a bigger circle like this, then this, let us say C2 and C1, so these two circles are touching only at one point. So therefore the condition will become C1 C2 should be equals to R1 plus R2, right? So with this you have to first of all calculate and try to get to the result, right? So I leave it up to you to try, and then we'll move forward to discuss about the solution of this problem. Okay, so try it up and then we'll discuss about the solution. So try to solve it. All right, so let us try to look at the solution, how we'll proceed with this question. Okay, so it is very simple that the center of this another circle or the smaller circle, we have to find out. Let us consider the particular center as some h comma k, right? So if I consider that particular center to something like, let us say, the center of this particular circle as h comma k. Now this and the circle C2, which is this particular circle, is already having the center as 0 comma 0. So the C1 0 distance is going to be equal to h square plus k square, which should be equal to the radius of the sum of the radius. So that is r1, it should be square root of it, r plus, let us say this particular radius is r plus 1, right? This is what I will have as one condition. Right. Then a similar way, this particular another circle is also passing the point that is 4 comma 3. So and also please note that we have to find out the equation of the smaller circle, right? So we have to find out the equation of the smaller circle, right? So for the smallest circle, let us this C1, C2, let us say the point of intersection is point B, and let us say this particular point is A. Now, for smaller circle, this bigger circle, which is basically present over here, and also let us call this particular distance as point P. So for the smaller circle, this PB distance, right? This PB distance should be less than 2, right? So this PB distance should be less than 2. Now you have to note that this, let us call this point P as 4 comma 3. So this is my origin 0 comma 0. So from origin, this PC2 distance is basically equal to 4. Right, so let us say this is along the x-axis. Okay, so what I'm trying to mention is that this PC distance, this particular distance is going to come out as sorry, not 4, it should be 5, right? Very good. Yes, it should be 5, right? Correct. So this PC2 distance should be equal to 5, right? Now sorry, it should not be 5, it should be, sorry, 4, 5 minus 1, that should be 4, right? Correct, that should be 4 only, right? It should be 5 minus 1, right? So because this radius of this larger circle is 1 unit, right? So from this to this distance is basically 5. So 5 minus 1, this PB distance will come out. So this is my PB distance. I should write it as PB, right? So this PB distance should come out as 4 units, right? So if my PB distance is coming out as 4 units, what I can comment is that this is basically going to be, and also I have assumed this particular condition such that this is P is lying along the diameter, right? So therefore the equation of line, um, yeah, let us say equation of the line OA or OP, it is going to be equal to y equals to 3 by 4x is equals to y equals to 3 by 4x, right? So considering this particular value, so if I try to put this particular value of y in my larger circle equation, that is x square plus y square is equal to 1, then I will get only one point of intersection. That means that will generate me a quadratic that is something like this, and which is going to give me that x is equals to plus or minus 5, right? So therefore this point B, which I will have as a point of intersection, that is going to be either be equal to so x is going to be equals to 4 comma 5 and y is going to be equal to 3 comma 5, right? So therefore the required circle, for this required circle I have the two diametrically opposite points, right? So therefore I can easily formulate the equation of circle from here. Okay, so from here I can easily form my equation of the required circle. Okay, that is going to be x minus 4 x minus, so x minus 4 into x minus 4 upon 5 plus y minus 3 into y minus 3 upon 5 should be equals to 1. So if I solve this result, I'm going to definitely get to the required equation of the circle that I need to get in my solution, right? Is this part clear to all of you? Is this part clear? Having fun? Bhaiya aap Bengali ho? Yes. Is this part clear to all of you? Great. So then what I can do is that I will try to leave some problems as a homework problem for all of you, and maybe you can try to solve those problems and let me know whatever solution you are getting by solving those problems. Okay. So I'm leaving one homework problem for all of you to try. So this is a very interesting problem that you all can try. So please take a screenshot of this problem. Please take a screenshot of this problem and try it out to solve it and let me know the answer in the next class. Okay, so next class when we're meeting basically on circles, we're definitely going to discuss about how we will solve this particular problem. Okay, so with this I hope this class was clear to all of you, and let us conclude the class over here, and we will meet again in our next class of circles, where we're going to discuss about the radical axis. We have to discuss about the question of intersection of the angle between two circles, and with that we will be almost done with our entire chapter of circle, right? I hope this particular discussion is clear to all of you, and I hope it like to help you out for your learning part, and therefore we can obviously use it up in our upcoming lectures, right? So with this, thank you, and I hope to see you soon in our next lecture. Thank you, and